Okay, top of the hour. Good morning, everyone. My name is John Gravel. I'm Vice President here at Lesman Instrument Company. I'd like to thank all of you for joining us for today's session. We're going to focus on the common points of failure which lead to leaks and contamination in hygienic processes. During the session, we're going to talk about equipment design, materials of construction for hygienic applications. We'll discuss the real reason you likely have a bucket of hygienic clamps that don't really work, how to keep seals from bulging into the process while still maintaining a tight connection, and preventing leachables and extractables from entering your process. And we'll, as always, we'll leave time for questions and answers at the end. Our speaker today is Mike Curnutte, who is the Jacoby-tarbox Hygienic Product Market Manager at Clark Reliance Corp. Mike has more than a decade of experience working with hygienic sanitary customers in the pharmaceutical, food and beverage, and flavors fragrance industries, where his primary focus has been educating the industry on developing proper material specs for the observation equipment needs. We welcome Mike and appreciate the knowledge and experience he's going to share. As mentioned, please note that during the presentation, microphones are going to be put on mute. So we want this to be conversational. So please type your questions in the chat box and we'll try and weave them into the presentation or address them at the end. With that, I'm going to turn the presentation over to Mike. Mike, the floor is yours.
Thanks, John. And thanks everybody for coming to join us today. I appreciate the audience. And hopefully I'll leave you with some knowledge to take away from this and an opportunity to connect further down the road. So as John outlined, the focus of today, for the first portion of today, we'll be talking about eliminating leaks in processing environments in the hygienic markets, as well as eliminating some of those potential sanctions. And we'll talk a little bit about it, but the common conceptions on topics like this is, why do I have a bucket of hygienic clamps, right? A recycling bin, if you will, of clamps that I discard because they're not working effectively. We also talk about the seal bulging, because that seems to be an ongoing problem within the industry where seals are wearing much faster than anticipated, and also preventing leachables and extractables from entering your process. That's more on the observation equipment side of things, but we're going to talk about the who, the what, the when, the where, the why, and the how, and then hopefully the now as to how we can take some type of corrective action to solve some of these problems. So the who. When it comes to these topics, every food and pharma manufacturing facility on the planet has these type of problems. They're not unique to your process, to your application, or to your facility. I've personally witnessed in just about every facility that I've been to around the globe that there are problems with leaking connections. And while there are some commonalities within these facilities, they're mostly not driven by your process conditions. So these are not unique situations. The what, the leaking connections, connections that cause system failures, they cause testing failures, environmental hazards, batch contaminations, and potentially injury to personnel, which is kind of the worst case scenario that we want to hopefully address. So when we talk about a leaking connection, most everybody envisions, something leaking out, dripping, but a leaking connection oftentimes can just be air entrainment. That can be a vacuum leak. If something can get out, something can get in someplace else in these processes. So with that, when we talk about certain types of equipment, something getting in is equally as bad, if not worse, as something getting out. The getting out just usually is how it manifests itself in showing that there is a problem. So what makes up a sanitary connection? And I gave a couple examples here. There are endless possibilities, but any type of ferrule to ferrule connection, clamped connection, the center one there would be a site port type connection that you're going to see usually on reactor heads and the tops of vessels for viewing into. The far right photo here is showing an inline flow indicator, uh, often used within your piping runs to identify whether you have flow or not, whether what you're seeing is actual production-based materials and or possibly a cleaning solution of some sort. So these sanitary connections are very common. I could have just as easily shown pictures of pumps and valves and things of that nature on here as well. Not something that we specifically specialize in, but I know that, Lesman, our partner, has these types of applications and equipment as well. So really anywhere where there is a clamped connection, that's what we're talking about when we say a sanitary connection. And I'm sure you can envision, hundreds of different applications within your facility where clamps are used. When does a union leak? There isn't a specific time. Anytime that you're in process, whether it's during commissioning, right at your process startup, normal production processing, maybe during a filling application where you're filling your delivery devices, during any type of testing, a union can leak anytime. If the process is running, there can be a leak. So when we talk about the when, we're really saying it's ever present. If that suite or that process is working, you have the potential for a leak. Now, there are certain times that leaks become even more present or issues become more present. We hear very commonly from a lot of our customer base that they struggle during startup when thermal cycling starts to build. So as your process begins and things are heating up, or during a steam cycle for cleaning, that's when a lot of these unions kind of show their ugly side. And through thermal cycling, you get expansion and contraction, you get gasket creep, you get a lot of things that can contribute to the when will it start leaking. Where? Anywhere that you have a clamp connection. This could be in your R&D laboratories, filling areas, your production suites, anywhere where you're doing testing, whether it be life cycle testing, things of that nature, you can have a leak. And those leaks, depending on the time that they happen, can be more costly than others. We talk about the ramifications of a leak. And while you're in a building that has miles upon miles of sanitary tubing and piping, and it's not uncommon to see a leak, when that leak occurs and where that leak occurs certainly will matter. If you're in a production run and you happen to have somebody from the FDA in your facility and they witness a leak, it's going to be an extremely expensive problem at that point. These facilities are manufacturing batches of product that can be in the millions of dollars. And to have the wrong person see a leak and see a drip, we must understand that in order for there to be a drip, there has to be a means for something to get in. If you can imagine, and everybody's probably done it when they were a kid, you put your finger on the top of a straw while it's down in your drink and lift it up, and the drink stays in your straw. But the second you take your finger off the straw, what happens? Everything runs out of the straw. So in order for something to get out, something has to get in. And that will be what your FDA inspectors are concerned about, is not that they saw a drip, but their request will be for you to prove that something didn't get into that process to contaminate your end product. We're talking about, in many cases, things that are being injected and or ingested into someone's body. So the concern for contamination and the effects that it would have on a batch of drugs will likely require that whatever is being manufactured at that point in time, that a potential contamination occurs will be discarded. It will not be able to be validated and approved. So, we're talking about something as simple as a hygienic union that all of those components combined probably didn't cost $1,000. And I have personally witnessed facilities that have been put under consent decree and cost millions upon millions of dollars to make the repairs required to eliminate that process or that contamination possibility. So you have to consider the end result and the potential damage that it will cause when we're looking at these potential solutions. The why. This is where things start to get a little bit more complicated and unique, and this is the area that we'll spend the majority of this portion of the webinar discussing. There's a number of factors that go into why a sanitary union can leak. It could be something as simple as poor alignment of the process piping. It could be that an uneven load, that the clamp wasn't set cleanly on the union before it was torqued down, right? It was pitched at a little bit of an angle. It could be the gasket style. It could be the ferrule alignment or the geometry of the ferrule. I have witnessed on brand new equipment that was trying to be installed that the ferrule A was not identical to ferrule B just because they came from two separate sources. We had an application where on a vessel a ferrule was actually warped slightly out of shape during the welding process and was not allowing it to mate with the sanitary gasket in the opposing ferrule in order to geometrically be able to be clamped together. Some of those things get extremely expensive. If you have a certified vessel, right? It's an ASME pressure vessel, and it's been manufactured, it's code stamped, and now you identify a problem on a vessel. To make a modification to that vessel, that tank has to go back through all of its certifications, right? So if we're planning on the solution being, hey, let's cut that ferrule off and re-weld another ferrule on and see if we can do it without warping it this time, that is a much larger problem than that solution sounds to be. Very expensive. Generally, it's going to not happen on site, so that tank is going to have to be removed, sent back, or sent somewhere for the repair, the recertification before it can be reinstalled. So things like that tend to get extremely expensive and extremely complicated very fast. But most likely, all of those things that are listed and many more are just parts of the problem, right? The biggest issue that we've seen as to why a sanitary union fails is due to the tolerances of all of the components combined, along with the stacking of those tolerances, right? So ferrule A from one company that's welded to a vessel, ferrule B that's from another fittings company, the gasket, and then the clamp, all combined. And those tolerances, even though every one of those products was likely within the required tolerances by the manufacturer, as they are applied together, you start to get tolerance stacking. And now you're going to try to clamp all of these things together. And that clamp in its own right has design features and or lack of design features that can accommodate those things. So when we talk about tolerances and tolerance stacking, it's not that any one of the products that you have are necessarily bad or out of tolerance, but the fact that one could be on the smaller side of the tolerance and one could be on the larger side of the tolerance, and now we're trying to mate them together, that starts to contribute to the problem of making things not fit perfectly. So tolerances and tolerance stacking has an influence on why you have a leak. Tolerances for every component compound on each other. There's machining tolerances in all of the metal components. Those machining tolerances literally will change from part 1 to part 100 just with the wearing of the tools that are creating them. So there's a frequency of the validation of the equipment and the testing methods to determine, right? Even your tolerance testing, your gauges and things that you're testing have to be recertified, recalibrated. There are tooling tolerances for the molds and dies that are used for the elastomers. Some forms of dies and molds are more repeatable than others, right? You've got the difference between a metal mold and or like a sand casted mold where they wear at different rates. They wear faster during certain manufacturing applications. You've got the elastomeric properties of the gaskets changing just based on the formulation, right? So if I'm using an EPDM versus a Viton versus a solid Teflon, all of those durometers of those materials change that can allow some tolerance creep as to the overall thickness of the gaskets when it's compressed. You've got specific proprietary dimensions that manufacturers follow. So, and we'll talk about it in an upcoming slide, but you know, the ISO standards and the BPE standards for manufacturing these products, one, are not identical, and two, they've been developed. Some of them, BPE specifically, have been developed fairly recently, most likely more recent than some of the equipment that's in your facilities. So you probably have equipment that at the time was certified and met every requirement, but now the requirements are starting to change. They're starting to BPE is starting to sharpen their pencil and look at these things because things like leaks have become so costly in facilities that they're trying to find ways to mitigate them during the manufacturing of the components and the equipment that are used in these processes. So the natural reaction to a leaking joint, right, to something being a little bit off, is to over tighten the clamp, right, or retighten the clamp. So when you try to overcompensate for these differences by forcing a solution like over torquing, that's where you start to get gasket bulge and things of that nature, where you really are just creating another problem trying to solve the problem that's most in your face, right? I see a leak, I need to retighten that clamp. Maybe the clamp has a specific torque value, or really it's not the clamp that has the specific torque value, but it's the elastomer that you're using that probably has a specific torque value to accomplish that seal. And now I've had to take that clamp up much higher in torque in order to try to get a seal because it's not working. So over torquing the clamp to seal that leaky union is probably the most common attempt to solve the problem. And really all it's doing is creating other problems. So ISO and BPE have tried to create symmetry. The allowable tolerances that we've talked about being able to compound on each other, but really BPE, which is probably the biggest kind of regulatory standardizing body in all of pharma, only started doing this in the last 10 years. So if you have equipment in your facility that's more than 10 years old, and most likely if you're an older manufacturer, whether it's food, whether it's pharma, whether it's flavor and fragrance, anywhere that a hygienic application, heck, we have industries right now that are younger than 10 years. So when you look at things like cannabis extraction, right, the THC extraction from the cannabis industry, that industry hasn't even been around for more than 10 years, kind of wide scale. So you look at those things and you say, how can industries that are as old as food manufacturing and as old as pharma manufacturing be uh, regulated by a body that's only been focusing on this for the last 10 years? Well, it's easy. They work off of a where you are today. So all of that equipment that you have in your facility is grandfathered in because it's been through the validation process. The problem is that it was validated, and it could have even been validated with those leaks present if they weren't present at the time of validation. So when you look at these opportunities to say, how do I accomplish bringing my facility and my production capabilities up to the current BPE standards without spending, what could be hundreds of millions of dollars revamping facilities, there are some ways to accomplish better performance without spending hundreds of millions of dollars or even tens of millions of dollars. That brings you to the how. So how do we fix it? What do we do when we see something as simple as a leaky connection? How do we address it? There's a variety of solutions, and I'm not here today to tell you what is right for your site or your application, but I will say that picking the right one for your site or application is imperative to control the costs. We had a customer that had an issue with a leak in front of an FDA inspector. They threw away several $1 million in product, and their solution was, we would like to standardize on a clamp that solves the problem. So they sought out an engineered clamp that could actually accommodate some of the issues that they were having with fit of their sanitary unions. But there are many, many applications, right? Piping can be brought into better alignment. You can, adjust your pipe hangers to make sure that if your ferrules are not lining up properly, that you bring them into better alignment before you try to clamp them. Elastomers can be changed. Maybe there is an elastomer option for you that has a softer durometer or a better crush capability to where you're achieving a better seal and you're still keeping up with the requirements of your process. Sometimes these things will cost you a little bit of money, a little bit of time, but they're certainly better than the alternative. I've even had customers that have suggested and or gone ahead with modifying vessels, right? Yes, we know we're going to have to take this vessel out. We're going to have something cut off of it. We're going to have a new fitting welded into it and recertified. But that's still cheaper than throwing away product or rendering that piece of equipment useless after they've spent the money to have it manufactured and installed. So many of them can be very costly. They can require revalidation of the process. They can require recertification of the equipment, right? Chances are, if you need to make an elastomer change, that's a wetted component, and you may have to revalidate. This is why I stress to facilities when we talk to them during your validation process, your original validation process, make sure that you're validating more than one option, right? If it's a gasket, if it's a piece of equipment, have contingency plans for things like, hey, we identified that gasket works in 90% of our connections, but in 10% of the connections, we also need a different seal method or a different seal material so that we can accomplish that effective seal without having to start over after we've already kind of written the playbook. So include some of those things into your validation process to say, this is a contingency plan, right? We know that EPDM, or we know that Viton works, and we know that solid Teflon works. So we'll validate the process using all of those, as opposed to using just EPDM only to find out that EPDM doesn't work in this particular application because of our temperature variations or the caustics that are involved with our cleaning and sanitation programs. So if you have a leak or a problem union that requires some type of repeated attention, meaning for some reason, I've got to continuously be revisiting this connection. And believe me, your maintenance folks that are out there, they know them. They know the problem connections. Their solution oftentimes is to take that clamp that they're assimilating as the problem and throw it in the recycling bin and go get another. The issue with that is generally the clamp that they're bringing in is exactly like the one that they just took out. So they're not really solving the problem. They're just giving off the appearance that they're solving the problem by, hey, I took that clamp out. Maybe it was worn and maybe a new fresh clamp of the same style might work. Clamps do have a life cycle. I can't tell you what that is because everybody uses them differently, but they do wear. They're a wearable component. So there are times when you are going to put a clamp in the bucket that deserves to be there, but there are also times that the clamp went in the bucket just for the simple fact that it was easiest to suggest that the clamp was the problem and not some other underlying problem. With all of that being said, I will say that a better designed clamp, and this is where I toot our own horn just a little bit, so bear with me, but a better designed clamp, like our GRQ engineered clamp, we've actually taken much of the material that we've talked about up to this point into consideration when we designed this clamp and manufactured it. So things like these tolerances stacking, the reason why it's a problem for some clamps and not ours is because we actually created into the internal geometry of our clamp a much wider acceptance of the tolerance range. So if you look at our ID of our clamp and the shape and the geometry of the machining and the tooling that has happened in our clamp, it actually is more accepting of ferrules that might be misaligned. It's more accepting of a harder durometer, larger gap needed for the harder durometer elastomers. So there is a way to manufacture a product. Not saying that it's going to be the everyman solution, but it will solve more problems than it won't. Right now, if something is just horribly misshapen, the weld job on it was very bad, and the thing is out of round, then a clamp that wants to fit on a round fitting is never going to be the solution to that problem. But a better designed clamp will solve more problems than you think it would. So the now, what do we do now? We've got a leak. We've hopefully not allowed that to be a larger, more expensive problem up to this point, right? We haven't had an FDA inspector take us to task on it and make us throw anything away yet. So what do we do now? Well, the first step is to stop accepting what can be changed, right? If you have a continuous problem, or even if it's a problem for the first time, what I don't always see enough of in these facilities is any type of root cause analysis to say, why is that leaking? Is it leaking because of the process conditions, right? Do I have an elastomer that just can't handle the steam pressures, or it just can't handle the caustics of the CIP solution that I push through that line to clean it? Do I have piping misalignment, or do I have angular, ferrule misalignment? Do I have a clamp that can accommodate the tolerances for this connection? Stop applying the same solution when every situation is unique, right? The answer is not always get a new clamp. The answer is not always change elastomers. Every situation should be approached as a unique situation, and we need to find the solution that works best for it. speak up and identify the solutions that are causing your risk exposure, right? So many times people look at these situations and they say, you know, we have leaky clamps, right? We change them. And they don't see the forest through the trees, right? The risk of a leak viewed by the wrong person at the wrong time could be in the millions of dollars. And throwing another $4, $6, $10 clamp at the problem won't always be the right solution to limit that risk exposure. So when I say that I've physically seen this, I have a local facility that the facility belonged to a different company previously. That company was put under consent decree by the government. And to this day, I was just there a couple weeks ago, to this day, there are buildings on that campus that are still under consent decree and have actually been deemed too expensive to repair. And they've just allowed the buildings to go dormant. They're locked, they're blocked off, and they're not in use. All because an FDA inspector didn't like something that they saw during a walkthrough. So when we talk about millions of dollars, we're not talking about just the product. We're talking about all of the time, all of the energy, all of the revalidation, all of the hurdles and hoops that a company will have to go through to satisfy the government that their processes, their equipment are all suitable to make something that is eventually going to be injected or ingested into a human being or animal for that matter. So that's the conclusion of the leaking portion of the presentation. You know, certainly I would love the opportunity when we have these conversations with folks. Nobody typically wants to air their dirty laundry and say, oh yeah, we have that problem. And that's fine. But we are always more than willing to have those private conversations with folks to say, you know, we'll sign NDAs or whatever are necessary to come in and help you solve a problem, because the risk is just far too great to continue to do nothing and expect that the problem will get better on its own. Is there any, John, I'm not seeing the chat. Is there any questions or anything when it comes to the clamping stuff at this point?
Yeah, Mike, there's a couple that came in on clamps. And one, I think, I'm going to try and paraphrase it. The gist is if a clamp isn't leaking, is there a time that it has to be swapped out?
Okay.
Why can't I keep using it if it doesn't leak?
Yeah, no, that's a good question. So I'm not here to tell you to change out all your clamps and that our clamp should be the one you change it out to today. Obviously, if you have these facilities have thousands of clamped connections, and if your clamp is working effectively, then I'm not here to tell you to change it. If it's not broke, don't fix it. But the other side of that is that certainly there are connections that give folks trouble, and all we're suggesting is that in what tends to be viewed as a commodity product like a clamp, there isn't a lot of thought given to, is there just a better clamp out there, right? Is there a solution that involves me changing the smallest, least expensive component on this union and fixing the problem? So no, don't change it if it's working for you, right? Certainly, I don't recommend making changes where problems don't exist, but I think there are enough problems out there that when we walk into facilities, those are the those are the opportunities that we're looking for. We're not looking for, I want to sell you $1 million worth of clamps today. I just want to sell you one clamp potentially that solves $1 million problem. You know, we get a lot of customers. I actually was with one over in Philadelphia a few weeks ago that they've specified a clamp, a particular clamp, but they found that in certain applications, that clamp is having troubles. And now they're up against an issue of, okay, well, this is the only clamp that we validated. This is the only clamp that we approved. We have to go through the approval process to get a new clamp. That's all well and good and likely an exercise that should be done, because I think if you paint yourself into a corner with specifications that are so rigid that they don't allow you to seek solutions to problems, then certainly at some point in time when that problem arises, you're going to have to deal with it then. I would much rather see companies look at the quality of the components in the forefront and not say, hey, you know what, I need to be single sourced because we want everything in this facility to be the same. Having everything in the facility is the same, is generally only easiest on the people that have to do the buying. They make it easy on themselves to say, we're only going to use this clamp without any knowledge of really the other products on the market that are designed for specific solutions, right? We make a clamp that is specific for rupture discs. At this point in time, I only know of ourselves being somebody that makes a specific universal rupture disc clamp that works with every rupture disc on the market. So if they have a particular clamp that they're using now currently for rupture discs, and that clamp, in some cases with a certain type of rupture disc, breaks that tab off, right? The identification tab on that rupture disc. Now they've just thrown away a several $100 rupture disc because they tried to force a clamp that it didn't work for. So situations like that are what we're looking to identify and say, look, let us be the solution to some of your problems. We're not going to be the solution to all of them, but if your clamps are working fine, yeah, don't change them.
So that leads to another one. I think the comment on the rupture disc.
Mm-hmm.
Is there a pressure or vacuum limit for your clamps? It's a question of application.
Yeah. So, I mean, all of our clamps have pressure ratings just like everybody else's on the market. I believe kind of starting off our lower size clamps, and generally the pressures kind of degrade as you get up into larger nominal sizes. Our 1/2, 3/4, and inch and a half clamps, and I think even up to our 2-inch, are all rated for 50 bar, which is like 725 PSI. In most cases, your processes won't even be able to generate that much pressure. And then the larger you go, as you get up to our top size is a 12-inch. I think we're still at 145, 150 PSI, which there is nobody on God's green earth that is putting 150 PSI into a 12-inch line. That's most of the time asking for disasters. So that does lead me to one thought I want to share, just because that's a great topic. We have customers that have used and they've validated and they've standardized on high pressure clamps. And high pressure clamps have their place, and they're generally in places where high pressure is certainly occurring and a concern. But most of the time, folks are standardizing on high pressure clamps, not because of the pressure that they can withstand. They just like that 2-bolt design. They, for whatever reason, feel that a bolt on both sides of the clamp is better than a hinge on one side and a bolt on the other. And I won't disagree with them for certain manufacturers. I've seen some fairly shoddy hinges on some clamps. I mean, literally stamped sheet metal hinges. that don't do anything for the clamp's performance or operation, right? They're kind of weak, they're flimsy, they don't align the clamp segments into any type of lineal shape where they're not parallel or they're not able to hold the two halves of the clamp in parallel. And in those cases, when you're using a 2-bolt, you're preventing that. But you can also, with a better engineered clamp, RGRQ has an extremely robust hinge. I mean, it's a cast component that's got the same body thickness as our clamp itself. You don't need to go to a high pressure clamp just because you want the clamp to perform better. You need a high pressure clamp in high pressure applications. And other than that, you need a well-built standard clamp that's easy to use, that's easy to flip. You know, you'll talk to the maintenance guys and gals, they like to flip a clamp over the connection. It's almost like one-handed operation. A good quality clamp can still do that and be a single pin or a single bolt type clamp without going the way of we're going to use double bolt clamps, which by the way are far more cumbersome to use. You have to have two hands to put it together. You have to torque them evenly on both sides, right? Because you don't want to bring the left side of the clamp down together. It's kind of like putting your lug nuts on your car, right? You don't take the lug nuts and drive them in a circle around, right? You want to bring them down evenly so you're getting even compression on both halves. So certainly there are applications where you just need a better quality clamp, and we'd love to throw our hat in the ring. I think our clamp is by far and away the best clamp on the market.
Got it. We're in the back half of the hour, so we should probably keep moving. Can you move on to?
Yep.
Thanks.
So we got a couple slides here on contamination from leachables and extractables. I talk about this because my background and my specialty has been glass and processing environments. And I came through in the last decade in a time where glass was certainly in the food and beverage industry. It was looked at as, how do we get rid of it, right? How can we prevent glass from being in our process? And for me, I don't like the idea of trying to eliminate glass from a process just on the grounds that it's glass and everybody's afraid of it. So process observation equipment, just like fittings, they're not all created equal. Just because you can see through a window doesn't make it equal to something built better, made to handle the rigors of an environment that it was designed for. So the materials of construction often differ. So, you know, when we look at glass, there's a handful of types of glass on the market. And we certainly want to make sure that we're using the right materials for the job. So glass is highly susceptible to degradation in your processing environment. Selecting the right glass for your application is as important as choosing the right elastomer, and it's just as easy. Most everyone is familiar, if you're in pharma, most everyone is familiar with the USP's class rating system for elastomers, right? So for an elastomer to be classified as a class 6, and that's what everybody wants. Every spec you'll see is all of my elastomers in my facility have to be class 6. So in order for an elastomer to be classified as class 6, it must be tested either in vitro or in vivo. So that's either actually putting it into a test subject or testing in a Petri dish. That particular test is called USP-88. So USP-88 is not a pass-fail test. It's just merely a test that says we're going to introduce this material to living cells. We're then going to test the result of how much cell death we get, and we will outline that against the parameters of our dosage and our life cycle requirements. Meaning, if something has a 30-day shelf life, then they're going to leave that test in there for whatever that safety protocol is. If it's 2 times the life cycle, they'll leave it in there, and then they will test to see exactly how much cell death they had in that culture. And that will be determined to say that is within our acceptable range or not within our acceptable range, right? Meaning that all of these things have to happen and then hold harmless to the patient. Glass has a very similar test, but it's a far less well-known standard. So you hear every time somebody talks about an elastomer, you hear class 6. But every time you hear or talk about glass, people don't bring up the standard or the type. Glass in pharma applications, right, is rated in a type structure. So USP type 1 glass is suitable for parenteral drug manufacturing, right? So ingestibles or injectables, which is the highest standard that USP classifies for. In order to receive a rating of USP type 1, those same type of tests, the in vitro or in vivo, are expected to be passed, and the elemental properties of that glass cannot be leached or etched into the patient, or in your cases as manufacturers, into the drug that will eventually end up in the patient. So USP type 1 glass is generally known as borosilicate glass in the industry. So if you hear somebody say borosilicate glass as part of their specification, that's a reasonably well-written specification, right? Because for something to be classified as borosilicate, it has certain elemental properties that have to be present. But to take that a step further, if it's USP type 1 borosilicate, now you've written an airtight standard on what all of your observation equipment should be required in those injectable and ingestible manufacturing facilities. The recipe, as it was developed to resist degradation during steam in place and clean in place cycles. These cycles are fairly similar, but not identical in food and beverage, right? They're still cleaning to a very hygienic level, but maybe not to the same scope and scale that a pharma facility would. But if it can pass the pharma requirements, it will pass everything else. The largest concern for glass in processing is failure, right? And when I say glass failure, every one of you is likely picturing glass shattering when I say failure. And glass shattering is violent, it's catastrophic, and it can certainly severely injure the operator on the other side of it, and it will contaminate either your process or the environment or both. So when we think about a radical failure, a catastrophic failure of glass breaks at about 5 miles a second under pressure. And that is as violent as it can possibly be for a piece of equipment that somebody will have their face on the other side of multiple times a day. So we try to make our windows, our process observation equipment, as safe as possible. In many cases, like with our Unisan windows, they are a glass window that is fused to a metal ring, that ring putting it under compression so that even in an overpressure situation, that glass cannot be blown out. So there are means of protecting from that catastrophic failure. But what about the other kind of failures? And these failures are far less common, they're far less talked about, but they are where the source of the leachables and extractables will come from on so many occasions. If you're putting windows into your process and they are not a USP type 1 borosilicate, and then you are interacting with them through steam cycles and cleaning cycles, you are pulling the elemental properties of those windows. Most of them are made out of soda lime glass. Soda lime glass is the most common glass in the industry. It's really the most common glass in the world. All of your drinking glasses at home are made from that. So it's not uncommon for companies to try to use soda lime glass where they can get away with it because it's easy to work with. The problem is it can't handle the system that you're putting it into. So glass in these processes can be eroded from inside, and it can happen so cleanly that you won't even see it happen. We've actually had windows that were taken out of service and showed to us that were made of soda lime glass, and half of the thickness of the glass was eroded from the inside, and it showed no visible defects from the outside. So there you go. You've taken a window that maybe was 15 millimeters thick, and it was made that thick because that's what the pressure temperature calculation said that it needed to be to withhold the pressure. And now it's half as thick, and it's still seeing those same pressures. So you have to make sure that you're using the right materials so that they can't be degraded by your process. The other thing that we run into oftentimes, I spent a lot of time on it in a larger presentation specifically about this, is talking about trade names and brands. It terrifies me when I see specifications from facilities that are written based on brand or trade name. And the reason for that is that brands and trade names can inherently be deceiving, and brands are bought and sold every day. So I'll give you the biggest, most relatable example. Pyrex. Everybody knows Pyrex for their casserole dishes, for their coffee pots. Pyrex came up with or Owens Corning came up with a type of glass that could handle thermal transfer, right? So you took a hot casserole dish out of the oven and you set it on your granite countertop and it exploded because the countertop was cold and the casserole dish wasn't. They created Pyrex, and Pyrex was for many, many years the brand that everybody knew and trusted and specified for their laboratory glass. Well, Corning sold Pyrex to a company called World Kitchen a while back, 15 plus years ago. And World Kitchen decided that in order to make their costs of production go down, we're going to go straight back to using soda lime glass. So there are casserole dishes and things on the market now that carry a Pyrex brand name that are made out of the same stuff that used to explode 20 years ago. So specifying and writing your specs with trade names or brands will create the illusion of safety and performance, but really you're not getting what you pay for. So you've got to make sure that documentation is in place, and that documentation and that standard and spec should call out for USP type 1 borosilicate glass for any laboratory quality stuff. So we'll just go quick closing, so we leave a few more minutes for any last minute questions. Leaking hygienic unions, obviously a costly problem. The root cause is multifaceted. The stacking of tolerance usually is the largest contributor to the lack of uniformity from one connection to the next. In selecting an engineered clamp that has built-in geometry into the engineering that accounts for some of this tolerance spectrum certainly will help you solve more issues than it will create for you. Might not solve every problem, but it's certainly the most economical first attempt at solving the problem. Then we talk about glass in the processing environments. Glass is very necessary in processing environments, right? You view through it to validate what your instrumentation in many cases is suggesting is happening, right? So we have all of this high quality instrumentation that tells us when we're having color changes, phase changes, maybe when there's foaming in the vessel that might be giving a false level. We go to that window to view the process. We want to validate, yes, it's foaming, or yes, the tank's been clean and it's empty. Certainly having a window to view through into your process, I believe, should be considered a critical component, but not all glass is created equally. You can write a non-restrictive specification that doesn't include brands or trade names and effectively control your process equipment. So brands and trade names, stay away from them. Lean towards classifying just like you do with your elastomers, right? You're not saying what type of elastomer necessarily needs to be used. You're just saying it needs to be class 6. You can do the same thing. You don't have to say what type of process observation equipment is being used, but you should say that it's USP type 1 glass, because that is the go-to classification for anything that's in a parenteral drug manufacturing facility. And that is the end of my slideshow. I'd love any other questions or comments.
Mike, one came in and it came in right as you were talking about the erosion of the glass. Is
Yep.
there a test to determine glass thickness? I think the question is, How did you discover, how did the customer discover that that glass had lost half of its thickness? Is there a
The
test?
act, well, it's not, there's not really a test. If it's found before failure, usually it's found during your PM cycles. So they will hopefully be taking these windows out during their, at minimum annual PMs and cleaning them inside and out. That was how the one that we found that had been eroded was identified. We did have another customer that actually they called us for a completely unrelated reason and suggested they had an inspector in that said that their lighting was not bright enough to visually inspect their tanks, and they wanted us to bring down lighting. And they had a light that was installed on a window. They never took it apart because it was a light on an LED light, or it was a light port on an LED light, and the LEDs were working fine and they were turning on and off. So it had to be that the light was just underpowered. Well, when we removed the light with the port, the adapter on it, the window was completely etched over, right? It had almost frosted the window with the caustic degradation. So I would say spend maybe not as much time, but always spend time looking at your window. We spend all of our time in the process observation world. We spend all of our time looking through the window. We don't really spend a lot of time looking at it, but you should make it part of your PM cycle to say, remove the window, check the wetted surface of it, make sure that we don't have any loss of material. You can also, oftentimes, if you're getting that leaching and extracting, you'll see signs of it inside the vessel, right? So if just below your window, you're seeing kind of like a white chalky residue left behind, that's generally the elements of the inferior glass that the caustics have degraded, and now it's running down the side of your tank.
Okay, just scanning here, seeing if there's anything new that's popped in. Looks like we've captured it.
Awesome.
Thanks very much for the presentation. Attendees, thanks for the time and all the questions. If you have any follow-up questions or a specific application, feel free to give us a call at 800-9-LESMAN. That's 800-953-7626. If you do not know who your account manager is, feel free to ask for me. I'll make sure you get taken care of. You can also reach me directly at johng@lesman.com. If you have any other topics that you want us to cover in our future webinars, please also send me an email with a subject and suggestion. We have lots of product and process specialists like Mike, and just let us know what we should focus on and cover so we can add value. At this point, if there's not any other questions, our presentation is going to conclude. Mike, thank you again, and attendees, thank you all. Have a great day.
Thank you.